The overall goals of the following experiment are to demonstrate the synthesis of porphysomes using a high-pressure extruder and the efficiency of porphysome-enabled photothermal therapy in treating tumors in a subcutaneous xenograft tumor model. This is achieved by conjugating pyrophenophoribide alpha to phospholipid to form the pyrophenophoribide lipid. As a second step, pyrophenophoribide lipids self-assemble into porphysomes by high-pressure extrusion and are characterized for quality control. Next, porphysomes are injected into animals bearing subcutaneous tumors to demonstrate their efficacy for photothermal therapy upon laser irradiation. The results show that porphysomes are nanoparticles with high homogeneity and highly quenched fluorescence, and that porphysomes are a potent photothermal agent based upon the 100% survival rate of the in vivo animal study.
Porphysomes are the first organic nanoparticles to serve as efficient photothermal enhancers while maintaining the drug loading capacity and biocompatibility of conventional liposomes, and suitable for multimodal imaging and image-guided therapy. So, implications of this technique extend towards therapy and diagnosis of tumors.
Prior to this procedure, pyrophenophoribide lipid were previously synthesized according to the text protocol. Separately, dissolve pyrophenophoribide lipid, polyethylene glycol, and cholesterol in chlorophyll.